see that? Greetings hobbyists, this is Arsans of Vol, and in this video we're going to have a look at how we can make our own node groups and save them for use in later files. So if you followed the channel, in the last video we were having a look at how we can make a set of nodes that's going to be able to work out the size of an object. And we were having a look at how we can use this in a node group version of an array. Now, I'm just going to get rid of all of this here, because the bit that we're interested in is these nodes, and actually this is really useful to have. So I want to be able to save this so I don't have to constantly write it out every single time. Obviously this is only 4 nodes, but it does take time and it would definitely be convenient to be able to do that. So what I'm going to do is I'm going to remove this, and so it's nice and blank, and I'm going to select these, and the first thing I'm going to do is I'm going to turn this into a single node. So if you just press Ctrl and G, you'll see that you go into the node. If I press tab, you come out of it and it's called node group. Click on it again and then press tab to go back into it. And we want to set the things that we want to be able to put in and out of this node group. So I want to have the object that's going to be here, so I'm going to put that into the group input. You'll notice now we've got that object as a definable feature on our node group where it wasn't there before. I'll tab back into it again, and then I want the X, Y and Z to be available as our group output. So I'm going to select that there and tab out, and you'll notice now that we've got the X, Y and Z. Finally, we need to rename this, and you do need to be careful with this. What you don't want to do is press F2 and just rename it there. You need to rename it in this part. So I'm going to call this object size, as that's what it finds out, and then you'll notice that goes to the top. If you do this by pressing F2, it doesn't have the same effect when you save it and try to bring it in somewhere else. Finally, I need to name it this, and you and Y, and it wasn't there before.
Polymorphs same thing.
Tab back into it again. That we name it there. So I'm going to want one file with and new objectives. Find wherever else. Finally, I need to save this file. So I'm going to go to File, Save As. Find wherever I want to save it, and I'll just call this, I don't know, Blender Geometry Nodes. And I've called it that because I might want to bring in other nodes later, and I just want one file where they're all kept in. Click Save As, and that looks like it's done. And then I'm just going to click File and New so we can see how this works. So I've got my new file, and if I bring it up so I can access my geometry nodes and go to this one and click New, we'd love to be able to bring this in here, but at the moment we can't. It's not anywhere to be found. So what you have to do is you have to go to File, Append, go to wherever you've saved this, double click on it, and then importantly you've got this option called Node Tree. And when you go into that, you've got, here we go, Object Size. Click Append, and now this is going to be available. If you press Ctrl and A to bring something in and you go down to the group, you'll notice you've got Object Size, and you can just drag that in, and here we've got it. We've got our geometry node. Now what's slightly frustrating about this is every single time I want to use this, I'm going to have to go into File, Append and bring that in. It would be really nice if you could just go to File and then set this up as part of your Save Startup file. Unfortunately, that doesn't work, or at least I haven't been able to get it to work. It doesn't save that you've appended this to the file as part of the startup menu. So you're going to have to do this every time, except you don't have to if you go and get yourself an add-on. So there's this add-on called Node Shelf. It does note that it's currently in a beta version, which if you find this on, you get Node Shelf it before you save a group and click New Setup. You click Load Group, or you could just click Load.
Okay, so that's done. Let's check it. Okay. First, group input, understandable basic stuff. Base geometry sent through editor settings. Blossom or randomized floor number. Okay, understandable. Minimum number of floors, max number of floors. Okay, what's the minimum maximum here? What is this? No idea. randomized what? I forget that. Module width. Okay. Height. Okay. And let's go with editor settings first. Go to basic stuff. Randomized number of floors. Mesh island. How does this work? Okay, so what is mesh islands? Geometry. Okay. Okay, wait. How do I? Is this enough? Can you hear me? I think you should be able to hear me through this now. Okay, geometry not random. Mesh island separate, disconnect piece of mesh within the same object. Each island the connects with these edges and faces that are not linked to the parts of detection. Mesh island node related operation can identify itself. Each island with its unique index, allowing you to process them individually. Okay. So each of these islands are given an index. Index of each vertex island indicates based on lowest vertex index the content of each island. Integer field based on. But how? This comes in the end because you have to first put the islands, no? Replace each island with an instance scattering box separate. Processing will generate a variation based on island sponsor size. Mesh island. That's mesh island. Randomized value is just basically random. Minimum number of floors. Wait. Oh. Wait. 1, 2, 3, 4, 5, 6, 7. It's not randomized. Store named attribute. It stores the result of field geometry as attribute special name. What is the base geometry? Ah, the plane itself is the base geometry. So in the base geometry there's a random value with each island. In the random values given an index, these random values are together, so I can change it. So it's not that important, I guess. Yeah. Then this geometry is put to switch. What is switch? Switch between two inputs. Huh? It's a boolean. This one. Use floor numbers of goes from vertex groups. Let's see what's named attribute. And reference to store information on which matches what is the geometry types, unlike temporary attributes which are used internally. Named attributes are saved with the object and can be associated for different parts of the world. Even the blender even name can store data like float, integer. Oh, wait. Let's get to the new tube because why? Okay, let's see.
Machine learning engine.
No. Okay, now let's see another example.
Need a UGC video
my-
for your business?
my.
Find me and many other skilled.
No. Okay, now let's see another. It has of geometry. Okay, let's go to geometry nodes, create a new file.
Aye.
I'm going to close this. And let's bring stored name attribute. As you can see, this node have an input, an output of geometry. So that means that this node only works in the middle of this type of wires, the
Yeah.
green ones. Because basically what those is to get the information in the middle of some process, for example, between these two nodes.
Yeah.
Now, why it's called a store name attribute? It's called a store name attribute because basically it stores safe data, information. Which type of data? Attributes. And why it's called name? Because when we store this type of data, attributes, we can give a name. Where?
Okay.
Here. That's why it's called store name attribute. Now, to see this, let me open a spreadsheet. And here, in vertex of this geometry, we can see the position. This is an
Okay.
attribute. It has the position of every vertex of this geometry.
Oh.
Now, what we can do is to create a new attribute. Here, how? Giving a name here. So let's write, for example, 8. And now that I create a name, it creates an attribute called 8. And it
Okay.
appears here. And it says that every vertex have 0 values. Why? Because the input is 0. So basically, we are storing a new attribute that we created with the name 8 with the value 0.
Okay.
And we can see it here in the spreadsheet. Now, if I change this, as you can see, it's going to update this column,
Makes sense.
as you can see. Now, this is a flow. That means that this diamond, that is
Yeah.
gray, is a type of data, a value,
can go
a flow.
points.
However, we can change the type of attribute
In
that
decimal
we are
points.
using. Clicking here, as you can see, if I make it smaller, this list is data type. That means the type of data that we are storing. If I want to have full numbers, I can select integer.
Yeah.
And now this color change,
That's whole number.
and these only have full numbers, no more decimals. So I can select, for example, vector, and now we have a vector, we have a different color, and we have 3 columns. Because a vector, remember, is 3 axes, x, y, and z. So I can say, look, 1, 2, and 3. This is the data that I want to store it when I select a vector. So you can see, we can store any type of data. You have more data types here, but the most common are float, integer, and vector.
Yeah.
Okay, now something important. Let me select, for example, float and select 10. If I use another store name attribute here, and I use the same name, for example, 8,
Okay.
now, as you can see, it doesn't say 10. So if I need this, it says 10. As you can see, it's the same. However, if I use the same name attribute, so the same word,
Oh, change
the value
it.
that matters
Okay,
is
okay.
the last one. So that's
So
why
there's
now it says here,
priority.
if I select, for example, 20, it will say 20. What I mean is that this value now doesn't matter. I can try to change this. That doesn't matter. Why? Because this one updates, override this value, the previous value. So the important point is that if you use the same word, the value that matters is the last one. However, if I change this word, for example, I write money, now, as you can see, we have 2 different
Okay.
attributes. This one is the previous one, and this one, this one. For example, I can select integer. Now you can see better. So if you use the same word, the last node with the word will update the previous nodes with the same word. This is very important to understand. Now, instead of writing you the value, what we can do, for example, is to add a float. For example, a random value. This node is a float with random numbers with a field. That means that if we can this here, now is storing these random values between 0 and 1. And this type of lines that now have dashes, that means that is storing more than one value, more than 1. And we can see it here. That's why now we have different numbers between 0 and 1. But maybe I want to say between 0 and 10, as you can see. Or I can change the city. And we can do the same here. For example, we can use random value, but integer.
Where they were using a random value too. So the value is random. What do you name this? Building level point. Am I just blind or where is point? What is this going to? This goes into switch. I should search here, but I don't know how. Control F? No? No, it's not. Ah, here. Why is it on 0? The value of the stored data is randomized. Oh, the levels of the building is randomized. And the ID is put through. Was that ID for him? What's ID here? Field based on. Okay, it's index. Wait, what if you remove? Shit, what the hell happened just by removing that? Oh, now it's randomized. Okay, now it's randomized. That's why it's. Yeah, it's randomized. How does this not affect randomization? That's our DeepSeek. Okay. Missions are assigned to a unique ID in this for each disconnected island. Island count tells you how many islands exist. 8 in my case. How do you know it's 8? 2, 3, 4, 5, 6, 7. No, 7. One, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Huh? Was it? Why didn't it? Is it because it was 8 already? 8 is just cancelling it out? Oh. 1, 2, 3, 4, 5, 6, 7, 8. And I only sent 8th seed. Ah. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, it is randomized. It's not okay. It is randomized. I'm just dreaming. We were just lucky, like 4 to 5 times in a row where we got the same digit. It makes sense. So that's randomized, and the Shalom just gives an identity. But if it gives an identity, then why is it isn't there? Is it? Wait, could it be that? Wow. Could it be that this guy who did this just extruded the plane all the way up and on extrusion wherever there is like space, he converted the area into these islands, and these islands have this preset models. Could be, no? And this height is actually the amount of extrusion. It'll work like that. Okay, named. Let's just finish this.
And now it's going to store a list of random values between 0 and 100, and you can see it here. If I change the seed, you can see that basically is storing random values. Okay, so now you understand how this works. Now the main point, why we want to use this type of nodes. We want to use this type of nodes because usually when we add a lot of nodes of geometry,
do you often find yourself surrounded by a tower of books all waiting to be read?
Yes.
You eagerly collect them and
we lose some information. So thanks to this, we can keep this information and use it later in the process. Okay, so here I have an icosphere, as you can see, thanks to this node. And basically what I want is to use the normals. Remember, the normals are the perpendicular lines that each geometry has, that comes from the faces and the vertex points. And I want to use this attribute, because this is an attribute, a vector, a direction, to later add UV-spheres. For example, a UV-sphere in each corner, each point, and I want to move it in the normal direction. So, to do all this, what I have to do is to use the node normal, because this node has the information of these lines, this vector, this attribute. Okay, so first of all, let's add UV-spheres in each point, each vertex, thanks to instance on points. So let's add on the points, on vertex, the instance like UV-sphere. Let's make it smaller.
Okay.
And now you can see, if we do a preview with Ctrl Shift left click, we can see that in each point, each vertex, we have a UV-sphere. Okay. Now, what I want, remember, is to create this animation that each UV-sphere is going in the normal direction, outwards. So to do this, we need to use set position. And thanks to set position, thanks to offset, we can move, displace all the UV-spheres in one single axis or all the axes at the same time. However, as you can see, all the instance UV-spheres are following the same direction. So I don't want that. What I want is that each instance, each UV-sphere is following the normal direction, so different direction.
Makes sense.
So to do this, we need to use the normal.
And
We need to use this vector with this vector. If we connect this directly here, we don't have any control. So what we have to do is to add in the middle a vector math. For example, in scale. Basically, it's multiplying this vector. So thanks to this, we can scale the normal. And in theory, we can push this instance in the normal direction, in these arrows that we saw before. So let's try it. And as you can see, it doesn't work. Why? Why it doesn't work? Why it's not using the normal attribute of this object? This doesn't work because when we add this here, we converted the geometry. So basically, we had a geometry with a mesh, vertices, edges, faces, where this geometry has the information of the normals, but after adding this, we converted this information to instance, as you can see in the output, in cloth instance. So in this process, we lost the normal of this object. That's why now it doesn't work, because it's like being empty. So how we can solve this problem? How we can say, hey, can you move this instance in the normal of this object? To do this, we need to use store name attribute to store the normal and use it later to not lose the information. So let's bring store name attribute, add it before we lose the normal. Let's display this here. And what we want to store? The normal. What is a normal? Is a vector. So let's select vector. And now instead of us giving a value, we want to store this because this is a field and its vector have a different direction. That's why we see this type of wire. Now we need to give a name. So let's write, for example, normal. We can choose if we want the normals of the point, edges, faces, or any other part of the geometry. I'm going to leave it in points. And now that we are storing this information, we can use it later. For example, here. But how we do that? To use this information, we need to use the partner of this node called name attribute. So basically, it's the same name except store. And thanks to this, we can write the same word. We can write it or select it in the list. And if we change the name from the list, like I did before, it will change automatically the type of object, like vector. We can do it manually, as you can see. But if you select it from the list, this list, it will change. So now we can use this and connect it here. So
So in other words, stored named attribute is the input of an function, or no, not function, of an integer. No, what do they call that around here? Oh, I forgot the name. Okay, whatever. So you store information, and you can name it in what many functions, you know, vectors and stuff, points, not vectors, but points, faces, edges, those things. We can store those informations in the format of vector, integers, and float, blah blah basic stuff. Value, if it's depend on the form of information, the form of values and values. Yeah. So normal. He said normal is the value. So it's right now normal. The normals of the icosphere, geometry being icosphere here, the vector being the xyz and on the points of the, which means the vertices. He stored information here. He continued the geometry along with the distance and points. He brought it up using set position. The position being offset.
Next to this, we are using the normal before
So
loop.
technically it's just store name attribute is just input and named attribute is the output. So if you look at it like that, here the named attribute of between float, he renamed it. Why would he rename it? Okay, what is attribute? Oh yeah, that's the value, right? Yeah, makes sense. What is it? Unknown socket value either. So he put it for multiply value 100 and with the value of it being building level. Where did he even use that value though? I don't know where he used it. Use it on the faces, which being these integer being something into 100 itself, just 100 itself.
Using after using this node. So if I connect this here, as you can see right now, let me select one again. This is working. It's using the normals of the original geometry.
Makes sense.
That's how we use store name attribute and its partner name attribute. So basically, this node is like if this is Wi-Fi, this is the modem, and this is your computer, your phone, and to access to this information, we need to use the same word, the same password. Once you use the same password, you are accessing to this information. So the next node can read this information. This is how it works. Now there is an alternative of store name attribute that is like the version of not using Wi-Fi. And this alternative is capture attribute. That basically is like the same, but with a Wi-Fi. What I mean? So here, the only thing you have to do is to select the domain. I'm going to select point. And instead of selecting the data type and give the value, we directly connect here the input. And now it gives you an output, and we can drag this and connect directly the wire.
Okay, so you don't have
here.
Okay.
And it's the same. So it's like not using Wi-Fi, using a wire. So it's similar, it's like the same. However,
that's Ethernet cable.
it's not so clean,
That's
you can
so-
see, because we have
that's
the
smart,
wires
smart.
in the middle, and if you want to reuse this information later, you will have more wires. That's why
Yes.
almost everyone use a store name attribute, because it's cleaner. So that's the difference between a store name attribute and capture attribute. In one node, you give a name, and you can use with another node this name, this password to access to the information. And when we use capture attribute, we don't need any password, any name, because we use a wire to connect it directly to another input, another node. Okay, now let's see another example how we can use store name attribute. For example, let's use a curve like a spiral or any curve.
Yeah, what is the
For
name
example,
again?
another node.
Capture.
Curve like a spiral or any curve. I have this curve and let's give a mesh. So let's use curve to mesh and let's use circle curve to convert it to a mesh. Let's select the tabs and make it small. So I have this curve. Let's select the material view. And basically what I want right now is to apply a gradient to this curve. And what I want is that at the end have a color and at the start have a different color. So the gradient, it will change
Gradient.
along this curve.
Cinema Core, an AI video editor.
God.
Tired of the hassle of
No. Okay, now let's see another example how we can use store name attribute. For example, this is a curve, like a spiral, or any curve. I have this curve, and let's select the material view, this curve. And what I have, we need to add here. And now what we have to do is to open the shape editor. So let's go to the shape editor. Here we have the material, let's check if it works. Okay. So to apply a gradient, what we have to do is to use a gradient, and in the middle, use a color map. So let's make it here. And as you can see, it's applying a gradient, but from here to here. As you can see, if I move this. And I don't want that. I want to follow the direction of the curve.
Yeah.
So we can do that. To do this, we need the factor. Remember, the factor is the information from the start to the end of any curve. So we need to send here the factor of this curve. And here we don't have any node to access directly to the factor of this curve. However, in Geometry Nodes, we have this node called spline parameter that have the factor, the information from the start and the end of any curve. So maybe what we can do is to send this information to the shape editor. So from Geometry Nodes to the shape editor. And this is possible. So how we do that? First of all, what we have to do is to store this factor. Where? Here or here? We need to do it when it's a curve. So here, in this process, because here it's a mesh. So here we need to use store name attribute. And now what we want is to select float, because it's a float, and use this attribute, this field. And let's give a name, let's make this factor, and now thanks to this, we are storing this information, as we know. And what we can do is to send this information to the shape editor, like if it's Wi-Fi. So here we have a problem. We don't have name attribute, but we have attribute. So attribute node is the node to read like this type of data, this type of password that we store here. So this is attribute called factor. So the only thing we have to do is to write the same word that we created to create this attribute, factor. And now, if we connect this here, we can use this factor. As you can see, it's working.
That's insane.
Thanks to this, it's reading the factor of this line. So as you can see, now this is working perfectly. The gradient is following the direction of the curve.
This is so useful.
Because thanks to store name attribute,
we could use this to, you know how when metal starts heating up, there's these things called, I forgot the name, but it's like where you slowly heats up, and it's like a coil, and it's a metal coil. I don't know what it's used for, but you can slowly heat it up, add emissiveness, and it's like with the orange color, be a good gradient. And then you can use the gradient to make it look, really good. Like it's starting to burn up and heat up.
we are storing this attribute, and we are sending this information to the shape editor, and thanks to this node, we can read this information. Another way to do it that I was doing at the beginning, and a lot of people do it at the beginning, is instead of using a store name attribute, what you can do is to, for example, let's open this, and what I'm going to do is to get the factor. So let's delete this and use capture attribute, connect the factor here, and now connect this to the input of the group output. And you will notice that here appears output attribute. So now if we write a name here, for example factor, like before, is going to work. So basically, connecting this here, thanks to capture attribute, because we need to capture this before it's being converted to mesh. You cannot directly connect this here, if not, it's not going to work, as you can see. It's like the old way to send information from Geometry Nodes to the shape editor. But as you can see, it's a bit ugly and annoying, and it's more steps. So it's easier to just use a store name attribute.
Yes, indeed.
It's cleaner, you don't have any wires in the middle, and it works perfectly. Once you understand how this works, you can use it in any project to send information from one part of the process to after any conversion, like we saw before, or from Geometry Nodes to the shape editor. Okay, so here I have another example. We have a grid that I create thanks to this node, and I have an external object, a UV sphere. And basically what I want is that when this UV sphere is getting really close to this grid, the color of this grid, of this plane, changes based in the distance, in the proximity.
Okay. Yeah.
So here I can get the information of this object, let's select relative, and thanks to geometry proximity, if we connect this here, we can get the distance between this object and this
And
object.
yeah.
So I want to change the color based on the distance. So what I have to do is to use something here in the shade editor.
Dreaming of IT but not interested in coding?
Yes.
Well, you're not alone. But you know what? You don't really need.
So let's store this attribute, the distance. Let's come here. Let's leave it in float because it's a float, as you can see. And let's give a name. For example, distance or proximity. Let's call it proximity. And now I can send this information here. So let's come back here and let's write the password, proximity. And now if we move this, in theory, it should work, as you can see. Let's add more vertices. And now something is happening because it's reading this information, the distance.
Nice.
We can delete this, we don't need it. We can directly connect this here. And as you can see,
Why delete? Oh, gradient texture.
we can now play with this to create this effect. And if you want to have more control, then what we have to do is to map range these values with map range. If you don't know how to use this node, I recommend you to watch my tutorial about how to use map range. So basically, thanks to this, we are controlling the distance of reaction. If I increase this, I'm saying to increase the distance of the color, as you can see, 2 meters. So this is another example how to use store name attribute to get the distance, the proximity between two objects, to send this distance to the shade editor and later do something with this information. For example, changing the colors. So I hope now you understand better how to use store name attribute, how to send information from geometry nodes to the shade editor, how to use capture attribute, and if you want to learn more techniques how to use this node, I recommend you to watch my tutorials about simulation nodes and other tutorials that I have in this channel. So if you like this video, please give a like,
Thank
subscribe.
you. The guy's peak, bro. I keep watching the YouTube videos for geometry node tutorials. Okay, so he stored the height, the minimum maximum of the buildings here and set it so that all the islands are in the same height. And after that, which is faster, whatever, he brings the attribute back, puts it through multiply and changes the value, which is then sent to switch if false. What is this? Randomize floor. Randomize floor numbers. Okay. Switch the randomized floor numbers. If false, it will go through this. If true, it will go. Wait, what is vertex doing? What information do you have? He switched it again. If true, then go to this. If false, switch with geometry group output. He named it number of floors. He sent the number of floors to be subtracted with 1. Let's go through middle floors first, because I think that's the one with the huge things. Let's clearly understand. Let's see how easy it is. Spline length. That's the curve length, right? If I remember. he divided it with the value of module width. What is that? Module width being okay. Am I in the right thing? No, I don't think. Okay. Calculate the number of modules to fit the wall length plus scaling. Spine length. Module. What do you do? The remainder of the truncated, what's that? Truncated division using F mod A B growth. Retrieve the total length of each line as distance or as number as points. Okay, yeah. He's got the length. He put it as one of the values, and the other value being the width. He divided them both, which means if it's 2, I don't know any difference, but that translates. Hidden floor. Is round it off, in other words. Largest integer smaller than or equal to a being the divide, whatever divide came in. Largest integer smaller than or equal. Okay, the next lower integer. So if I say like 9, it'll be 0. Then he used those two values. It's not until the remainder of the wrong. Oh, the remainder alone. What's truncated division? Oh shit. What is truncated division? Truncated is also known as floor division or integer division, and a mathematical expression that divides two numbers and returns the largest integer less than or equal to. That's just floor, but it will divide. Yeah, equivalent to floor. Okay. Understood. Okay, so he got spline length. What is spline length again? I don't know. Listen. Spline length. Spline refers to the arc length of a curved spline. Actual distance among the curves start to end. Okay, yeah. Normalized for how long? Okay. Okay, so he got a spline length, which is the total height. I think. What is the curve though? I just got a spline, which is a curve. Okay, you got the curve, you got the length of it, he divided it normally with 2.9 whatever, then he got the floor of it, which would be 2. Yeah, it would be 2 because the largest integer. And after that, this divided the height, whatever, then got the lowest digit, then divided both of them, then use that digit to be divided by 2, this being divided again by wait, why? Then add it plus 1 and combine xyz vector. Ah, this is so shit. Oh no. Okay. Why are you moving? Got the vector, he imported it into instance on points. So you got the size of the medium flows. Oh, he got the size that reduces these and increases. Ah, this size change in the x and y axis is because of these. Okay. So that's all there is to that. I don't understand what math he had in his mind. That is fine. Trim curves or remove wall overlap. Okay, understood. He got the length. He subtracted it with the value added from this. My god, what is he thinking when he's making this? This is so insane. Alright, let's take this chunk by chunk. Okay, so let's go with first. What do we make first? This is the height, right? But we need the model to be there to make the height. We'll just put something there. Use floor number of floors from vertex group. It takes the floor number from the vertex group. This takes it from random. But there's no reference to vertex group. What is that? Let's see how we can take information from vertex group.
Welcome back to the channel, and today I'm going to be addressing a subject that I get asked about a lot, so I decided to do a video on it, and that is how do you utilize the vertex groups in Geometry Nodes. So in this case, what we're going to be doing is setting up this example where we can paint on our vertex groups, and we can have these instances. In this case, it's going to be a cube as an example. We can paint it onto a mesh surface. So utilizing vertex groups is something that is possible in Geometry Nodes, and I'll show you step by step how to do it. And it's kind of really fun because it gives you a little bit more control, whereas when you're doing it completely procedurally, it's, you know, it's doable, but sometimes there are going to be instances where you really just want to paint on your instances. So let's jump in, and I hope you guys enjoy learning how to use vertex groups in Geometry Nodes. Okay, so let's jump into Blender. We're gonna just select everything and press delete. And I think a really good object to test with, even though you can use any mesh object, is gonna be a plane. So we're gonna go Shift A, we're just gonna go to our mesh options. Let's just quickly add in a plane. Where is it? Here we go. So we're gonna go Shift A, we're gonna go search, and we're gonna go instances, and we're gonna go instances on points. People look on this, it's way too big, so let's just take the size here, or just click and drag on it, and let you and bring it down. Let's get a trans, and just to make it look a little bit better, we can just take like instances. All you have to do here is just go Shift A, search, and get a join, and go for join geometry, and place it over here, and have the input go here. And now you can see your original plane and instances. So now we have a nice little setup here where we can try this out. Okay. Yeah. So the idea here is to do some vertex painting with a vertex group, and then have it only put these little cubes that we stretched out where we're painting. So how do we do that? Okay, so we need to actually come here to our instances on points, and we need to take our group input here, and we need to take the selection and drag it into one of these sockets here. So now we have a selection, and then we want to press N to bring up our properties, and over here under our groups, under our interface, we can take this selection and we can just call it vertex groups, and go enter. So now we know what it is. And let's create a vertex group. So make sure you click here on your object data properties, which is a little green triangle. And let's create a vertex group. Let's just call this instances, since we're going to be painting on our instances. And you can call it whatever you want. And then we go over to modifiers where our geometry node is. I'm going to click on this thing here. And now we can select a vertex group. So we just click here, and we're going to go to this one called point instances, because that's what we named it. And you're not going to see anything because we haven't actually painted anything in. So there are two ways you can do this. You can go over to your object data properties, and you can go into edit mode, and you can just select some verts, and that way you can just go ahead and you can assign them. And now you can see we have some vertex weights. Or a more fun way is just to go over here directly into weight paint. And with that instance selected, you can just come in here now and paint wherever you want to see your selection. If you want to, you can also come here and subtract, and then paint them away. You can change the size of the brush. It's really fun. So that is how you can work with vertex groups in Geometry Nodes. I hope you guys have enjoyed this, and I'll see you next.
Okay. Which means you gotta check this.
Here now and here, or whatever you. So make sure squeeze and open buckets here. So now we have selection. And then we want to press N to bring up our properties, and over here under our groups, under our interface, we can take the selection and we just call it vertex groups, and go enter. So now we know what it is, and let's create a vertex group. So make sure you click here on your object data properties, which is a little green triangle, and let's create a vertex group. And let's just call this instances. And then we're going to go vertex group.
What have I done? That shit crash? I crashed. Oh no. Huh? This thing wall from ground floor. Alright, okay, we understand basically we understand the basics, right? So it's just the grid or plane that is extruded. I still don't know how they're doing this though. where it updates on the real time.
First, we're going to just click here and we're going to go to this one called point instances because that's what we named it. And you're not going to see anything because we haven't actually painted.
Wait. Adele. Clean. Ah, shit. Okay. Alright, so basically, we have the object. He used this object because we can edit and we can, you know, grab and move stuff here. See, we can grab and move, which means it's actual. He used group input, and in the group input he extruded this. So let's try to extrude yeah, see, he extruded it, making you not be able to see the lower part, similar to how it looks here. Okay, he did that, and after that he got points to scatter on all these places. So how do we do that? The extrusion, this offset is going to be the height. So because it is made, okay, he didn't do anything for that. Blender has it like that. Okay. So extrude mesh is going to be the height. Okay, that's the building's height. Now we need to segregate the points, but to put those points in we have to somehow one way is to, oh, we can't because the plane. Should we just wait, let's dig a little more deep into the middle floors, because what is this? Do we middle floors? Where are we? Oh, we are all the way down there. Floor duplicates. Oh, he duplicates the element, set ID. He multiplied the index by the value of the height. What is module height? Which is defined by he got it from somewhere else, didn't he? Didn't touch boundary right here. Yeah, let's see. Okay, what it was, duplicate elements, put it as a curve through some what? Mesh to curve to. Why would you do this? Why? This is useless. He did something so useless. Is he trying to waste time? Because he converted mesh to curve to mesh, which just undid what he did, and then he split edges. I guess only curve to mesh. Mesh to curve, curve to mesh. So which means it's a mesh right now. Oh, it's a curve. Oh, it's converted curve here. Ah, okay, yeah, so. So if I do this, there should be no change because the mesh itself. See? It was useless. Why did he do this? These two are useless. Is it to like add selection? But selections are here. By adding selection it breaks. Wait, where did I connect? Okay. Is it just me or is it? Oh wait, yeah. Okay, yeah. Yeah, I think it's normal. Yeah, there's no need for that. Wait, let me check if I can update this. Yeah. This is happening because I did some weird ass edit. Yeah. Yeah. Okay, so these three are useless. Yeah. Okay. Works. He deleted the geometry. Oh shit, I messed up, didn't I? Yeah, I'ma learn this tonight completely. I'll understand it. I'll come tomorrow. I'll start working on the actual house tomorrow. Yeah? thank you guys for watching. I think this is the this is the first stream where I was talking and using Blender. IW.